In this video, we are going to compare solving linear equations and quadratic equations. They are both common types of questions with different methods because of what kind of question you're starting off with. So let me start off with linear so you know what I'm referring to. If I have a linear question, I might have an example like this. Solve for x, and I have 2 bracket x plus 7 equals 8. Now again, solving means this is a placeholder. What number goes there so that 2 times whatever that number plus 7 is equals 8. That's what solving is. It's different than simplifying, although simplifying is part of the process. But ultimately, you want to say, x equals some actual answer, whether it's a fraction, whether it's positive or negative. So how do we do this? In my previous video, I talked about using reverse BEDMAS. Often we say, well, let's expand and simplify first. Expand and simplify when possible. And then I can use reverse BEDMAS or reverse PEDMAS or PEMDAS or BODMAS, whatever you use. And so for me, that ends up saying Sam Deb. Okay, so I'm going to start by expanding and simplifying. If you're looking for a more detailed video on linear equations alone, I have an entire video for that, and I'll try to link it down below. So I've expanded. Now I can use SAMDEB. So I see I have addition right here, and I also have multiplication. So according to SAMDEB, I'm going to deal with the addition first. So when it goes to the other side, the operation changes to subtract. So I have 2x equals negative 6. And now I'm going to divide both sides by 2, and I get x equals negative 3. That's my one answer. Now there are various different, methods. There are other kinds of questions. So you could also have a question that looks something like this, x minus 1 equals 5x plus 7, where you've got x's on both sides. So what would you do there? I would move the x's, group them onto one side by saying, well, if that's 5x, I'm going to subtract 5x to both sides. From both sides rather. So I have x minus 5x minus 1. This is gone. I have 7. I have negative 4x minus 1 equals 7. And now I do the same thing I did above. So I'm going to add 1 to both sides. And now I'm going to divide both sides by negative 4, not just the 4. And that gets me a negative 2. So that's just a quick overview of some of the linear equations that you could be asked to solve. Now with quadratic, a quadratic equation is one that has what we often call a degree 2. So it has an x squared in it. So it'll either look like standard form, or it could look like factored form, where if you were to expand it out, you would also get a degree 2. You'd get x times x is x squared. Whereas for linear, we don't have that. So first of all, you want to be able to make the visual distinction between a quadratic versus a linear. So let's take a look at the 3 different methods that we can use. So I'm going to take an example that looks very similar to this linear one, but I'm going to put a square on that one. Now, I'm actually going to use SAMDEB or reverse BEDMAS for this one as well, and I'm going to show you how that works. So we used reverse BEDMAS for linear. It works for quadratic as well, but it only works in certain situations. If you look at this question, if I cover up the x, I don't have any other x's in that question. That's why reverse BEDMAS works. Same thing with this. If I cover up this x, imagine I could completely cover it. I don't have any other x's in the question, which means I can just isolate the variable using SAMDEB. That might not make total sense yet, but as we go on, I'll explain more. So if I'm using SAMDEB, I'm going to write that up here, SAMDEB. Well, what do I have on the left-hand side that I have to get rid of? I have a 2 times, so I'm going to underline the multiply. I have brackets, and that little 2 up here is an exponent, so I'm going to underline E. So according to SAMDEB, I want to deal with the times 2, and I'm going to deal with that by multiplying the entire left side and the entire right side by 2. The 2 divided by 2 reduce out to just be a 1, so we don't even need the 1 there. I'm just going to rewrite this as x plus 7 squared equals 4. According to SamDeb, I now have to deal with my exponent. Now, what is the opposite of an exponent? So the opposite of a square would be a square root. Those two things cancel each other out. So again, the opposite of a square is a square root. A square root will undo it. So what I want to do is, and I'm going to just move this down a little bit, I essentially want to take this squared, and it's almost like when I bring it over to the other side, it turns into that square root. So I'm just going to copy out my x plus 7, and instead of writing the 2, I'm going to say, well, when I move it over, it becomes the square root of 4. Now, the only thing is you always have to put a plus or a minus with a square root. I can try to explain that a little bit later, but for now, always, always, always have that plus or minus, and I'll explain what that means in a second. So I don't need the brackets there, I'll drop them. Square root of 4 means 2. Now here's why this answer, whatever I put in this bracket, could either be positive or negative 2. It can be positive 2 because 2 squared equals 4, well that makes sense. But it can also be negative 2 because negative 2 times itself, negative times a negative, will also give me a 4. So because I can have two versions, that's why we always have that plus and minus. Now what do I do once I have that plus or minus written down? How do I get my final answer? Well, you essentially have two different pathways. Either your x plus 7 equals the positive 2, or your x plus 7 equals the minus 2. Both of them would work out to giving you an answer that solves this. So we need to work through both of them. If we only do one, we end up missing out on one of our answers. So I'm going to subtract 7 from both sides now. I get negative 5. And over on the right-hand side, I'm going to subtract 7 from both sides again, and I get negative 9. So when you have a quadratic, and I know it's a quadratic because ultimately if I expanded this, I get an x squared. If it's in this format, I could just go straight to SamDeb. Just like how with a question like this, technically I could have gone straight to SamDeb. What if you tried to expand it? Well, if I expanded it, I'd actually end up with a question that looks more like, I'm going to do it over here, but let me do some rough work. So let's say I expanded this. I'm copying the same question. Now this becomes x squared plus 14x plus 49. If you're unsure of why, just remember there are a couple ways to look at it depending on how you were taught. Either you were taught this formula as a shortcut, or some of you would also prefer to write it out twice. Expand using FOIL or whatever method you've used, and that will get you this inside bit here. Okay, but the important thing is this does not equal x squared plus 49. You need that plus 14 there. That's a really, really common mistake. All right, so then those of you who want to expand might keep on going. You'd get 28x plus 98 equals 8. And then you'd say, well, I expanded it, can I use SamDeb now? And the answer is no, because if I were to cover up these x's, there's more x's there, so I can't just isolate one. So in other words, I can try to isolate that x by moving these over and then getting rid of the 28, but then I still have an x squared on this side. So I can't isolate it. I could try to isolate this one by moving these over, but then I have an x on this side as well. So you cannot isolate an x when it appears in two different places. So instead, if you had a question that was formatted this way, this is where you would use your quadratic formula. This is where you would make sure that one side is equal to 0. So I often say green light means go. You need to have, and then I color this green, you need to have this green light of a 0 before you're allowed to use the quadratic formula. Now the quadratic formula is x equals negative b plus minus root b squared minus 4ac, all of that over 2a. So let me take our question again. Let's pretend, maybe I'll write this in blue now. Let's pretend our example was actually solve for x, and this is the question we were given. Okay, so I can go straight into quadratic formula if I'd like. But I'm noticing that all of these numbers are divisible by 2. So what I could do actually, because it's an equation and I have a left and a right side to balance it out by, I could divide everything by 2, and that way I just end up using smaller numbers, which is nice. Okay, so if I'm using quadratic formula on that, let's pick out my values for a, b, and c. A is 1, b is positive 14, c is 45, and that just goes along with these positions of a, b, and c. Once I have those numbers, I feed those numbers into my quadratic formula. So x equals, I'm just going to copy this whole thing out, duplicate. Okay, and if you find yourself making silly little mistakes, I would encourage you to take 10 seconds to write that out. It tends to help avoid some of those mistakes. Okay, now I'm going to square my b minus 4ac. The entire thing has to be over 2a. Oops, sorry, and my a is 1. When I punch this into my calculator, I end up getting 196 minus 180. If it's okay with you, I'm just going to write that as root 16. So I'm kind of skipping a step. Now, root 16 is just 4. So this is what my question turns into. And then again, what do I do with that? What do I do when I get to that step where I have the plus or minus? So I had that here, the plus or minus. I have it again here. So just like I did here, I'm going to break it into 2 different pathways where one of my answers has the plus and one of my answers uses the negative. Okay, so here's my pathway. One of my answers, I'm going to copy all of that out, but it's the positive that I'm using for this answer. And for the other x, I'm going to copy that whole thing out again, but in this case, it's going to be the negative one that I use. Okay, if you're using your calculator, I'm hoping you can do this part in your head, but if you are using your calculator, make sure you do this, hit equals first before you divide by 2. Otherwise, your calculator is super smart and does BEDMAS even if you don't want it to, and it'll just divide the 4 by 2. So I have a negative 5 as my answer, which is what we had on the left-hand side as well. And here I get a negative 9. Okay, so those are the same answers because it was the same question. You know, this one was a lot simpler. So if you're able to use SAMDEB, it's a lot faster than the quadratic formula. And really, the quadratic formula should be your last resort. SAMDEB is a lot quicker. And also, there is another method that's a lot faster as well. So I'm actually going to take this part of the question and say, if I wanted to solve this, I used the quadratic formula for that, and it took forever. Before you launch into the quadratic formula, if you're ever in what we call standard form and you can't use SAMDEB, I always want you to check if you can solve by factoring. So here's the question that we're going to solve for. Solve for x, and I'm going to take that yellow highlighted bit down on the bottom left of my screen. With solving by factoring, you also need to have this green means go 0 on one side. But once you do, if you're able to factor this, especially if it's a simple trinomial, your working is really quick. So let me find 2 numbers. Often this is called the product sum integer method. So I want to find 2 numbers that add to 14 and multiply to 45. Bit of trial and error, I get 9 and 5. So when I when I put that into my factors, I get this. So this method works assuming you have learned how to factor. Once you've factored and one side is 0, we can peel each of these off and say, hey, if this bundle is equal to 0, then 0 times, I don't care what this is, equals 0. Great, I'll get one answer. If this bundle equals 0, same thing. I don't care what this becomes, but as long as this is 0, the whole product is equal to 0, because anything times 0 is 0. So I get x equals negative 9. Get rid of those brackets, they're not needed. And x equals negative 5. Okay, which is the same answer anyway that we had in these two methods. Okay, so let me summarize this. Let me summarize all of this. So we have linear equations, which we typically just use SAMDEB for, or if needed, we expand and then use SAMDEB, or sometimes there are more complicated ones like bringing your x's to one side. So again, that's a whole other lesson. Quadratics, how do we solve for those? Now, before I go to that, I do want to highlight that, again, solving means you have an answer for x. So no matter whether I'm dealing with linears or quadratics, the answer to my question, I'm going to make all those orange. The answer to my question is always going to be an actual number for x. All right, so if you're given a quadratic, how do you solve? It depends on the format that it's been given in. If you are given a format like this, where you only see one x in one position, then SAMDEB works really well. More often than not in high school, I find that we give it to you as a standard form question. And so most kids go, oh, okay, I know what to do. I do quadratic formula, but it takes so long and it's really easy to make little mistakes. So what I always tell people to do is if you have it in standard form, always try to solve by factoring before you do quadratic formula. If you're unable to solve by factoring because you forgot how or you can't find the numbers, so in which case it might be impossible to solve by factoring, some of them are, then you'd be forced to use this. If it's a question with decimals, then again, quadratic formula might make the most sense. But this is the difference and this is the comparison between the three different types. Again, I'm going to upload this chart that I just created up onto my website. I'll have the link in the description below. That way, if you'd like to print off a copy for your records, you can, and use that just to help you study. If you found this video helpful, please like and subscribe.